Hi everyone, welcome to the lecture series on low power VLSI design, and topic for today's discussion is metal insulator semiconductor, that is MIS structure, uh, which is the most fundamental concept in CMOS as well as VLSI design. Understanding this MIS structure is essential because it forms the foundation of mass capacitors and MOSFETs, which are the building blocks of modern integrated circuit. Let us move on to MIS structure in depth. What is this MIS structure? It consists of three layers. First layer is a metal layer which acts as a gate terminal. The insulator, which uses silicon dioxide. Electrically, it is used for isolating the gate from the semiconductor. That is why it has high input impedance when compared with the bipolar transistors. The next layer is semiconductor. It is generally a p-type or n-type silicon substrate where charge carriers are controlled. Unlike conventional conductor, the gate does not directly inject current into the semiconductor. Instead, it controls the movement of charge carriers using some external electric field. This electric field control is the key reason why MOS device consumes very little power when compared with the other semiconductor transistors. Let us go on with the basic structure of the MIS structure, MIS arrangement. From top to bottom, we have first layer as metal gate, and second layer is oxide layer, or it is made up of silicon dioxide and p-type silicon substrate. This simple structure is used in many electronic devices. Some of important applications include mass capacitors and CMOS transistors, memory devices such as SRAM and DRAM, and integrated circuit used in processors and communication system. Whatever communication we are preferring, whatever integrated circuit that is used, it for communication purposes like modulation, demodulation, and transmission purpose, everything this MIS structure plays a vital role. Almost all the modern electronic chip contain billions of these MIS structures inside a single IC. Now move on to working on the operation of this MIS structure. This depends, operation of this MIS mainly depends upon the gate voltage. There are three operating modes. First one is nothing but accumulation mode, depletion mode, and inversion mode. We will see one by one. What is this accumulation mode? So as I said, advantage of this MIS is depending upon the gate voltage, it will be resisting the power. So apply the electric field, it will be minimizing the power dissipation. So depending upon the gate voltage, we are categorizing these three modes. First one, accumulation mode. When a negative gate voltage is applied to a p-type substrate, what will happen in the sense, holes, which will be the majority of the charge carriers that accumulate near the oxide interface. As we are applying negative voltage to the gate, all the holes will be acting as a majority carriers that will be accumulating near the oxide interface. Now capacitance will become a maximum. Second layer is depletion layer. It is depending upon the gate voltage as a positive voltage. So when minimum, that is small amount of positive voltage is applied, holes move away from the surface, and initially it got accumulated, will be starting moving away from the gate surface, and depletion region forms, and as a result capacitance will be decreasing. This is inverse of the accumulation mode. Third mode is inversion mode. It is advanced version of depletion mode. When large depletion mode occurs when small positive voltage is used, whereas inversion mode when large positive voltage is applied. Electrons will be attracted towards the surface, and these electrons form an inversion layer, also called a conducting channel. This inversion layer allows current to flow between the source and drain terminals in the MOSFET. Therefore, inversion is the normal operating condition of MOS transistor. As a result, we want to go with large positive voltage, which makes electrons to get attracted on the surface. Now let us see the gist of what we have seen previously. This table gives the summarization of three operating regions. First one is gate voltage, and second one is what region is formed. When gate voltage is negative, accumulation region is formed, and when small positive voltage is applied, depletion region is formed, and when large positive voltage is applied, inversion region is formed. This relationship is very important because the operation of CMOS circuit is entirely based on switching between these regions. So depending upon the operation and application at which region we want to make the MIS structure to work, this gate voltage plays a major role to put your device in accumulation mode or depletion mode or inversion mode. Next we will go with importance of this MIS structure in CMOS. Now let us understand why this MIS structure is so important. MIS structure forms the basis of mass capacitors and MOSFETs and controls charge using the electric field instead of direct current. Since there is one coating in the gate, this electric field comes into the picture, has extremely high input impedance because of this extra layer, and draws negligible gate current because of the insulating oxide, and enables high density integration in VLSI chips. Its advantages are low power consumption and high switching speed, excellent scalability and high reliability, and it is easy CMOS fabrication technology. And where this application comes into picture is it is used in microprocessor application, general microprocessors. Instead of normal ICs, we will go with MICs, and digital ICs can be replaced with this MIC, and memory chips which is used for storing the data can also be used here, and CMOS logic gates can be used with MIS structure, and all the analog integrated circuit. Without this MIS structure, today's smartphones, laptops, AI processors and embedded systems would not be a possible application. So whenever low power comes into the picture, dissipation should be minimized. So if we want to minimize this dissipation, instead of going with CMOS structure, MIS can be preferred. To conclude, the metal insulator semiconductor structure is the fundamental building block of CMOS technology. By controlling charge carriers through an electric field, it provides low power consumption, high reliability and excellent scalability, making it the foundation of all modern VLSI circuits. Let us see in the next lecture series, and thank you all.